Hello, people. Gosh, it's good to see you, or actually, nice to know you're there. I hope you're doing well, and so here we go. I hope to, in the next few weeks, achieve three things as far as preparation. Prepare you for the AP test, prepare you for an exam. My last exam is next Wednesday. You have one exam left. It's mostly about series. And prepare you for college in Calc 3. So even though the AP test might not cover everything, you're going to need to know all Calc 2 for Calc 3. So I want to make sure you're ready. In other words, I want to do my job well. So here we go. First, a few things. A little general test info. You are at this point being inundated with AP information. And me, I'm done with it. I've just spent 4 hours reading AP stuff. Uh, so just so you're clear, I'll show you where it's at, but I'm not going to read it to you. Um, on Google Classroom, I put links to a few different documents. The first one you might have talked about in other AP classes, I don't know. But if you look at this first link, it's the exam info, and it looks something like this. And there is a ton of information there. It took me about a half hour to skim it. Um, And when you have time, if you want to, for some light reading, I think it's got good information there. You should probably read it. This second thing is an exam day checklist. I didn't think this was that great myself, but they said you should have one of these for each class and just say, yes, I'm ready, yes, I'm ready, yes, I'm ready. All right, so that's there. And then this might change May 4th. I guess they're going to come out May 4th with a video demonstrating how this is all going to work online and whatnot. This is something I found on the College Board website already, and it's basically a practice, exam. If you just type in practice here, you'll be able to see how to upload and practice uploading. But again, I hear on May 4th they're going to do that again, so you might hold off and see if they have some kind of updated version, although you can try this if you want. All right. The next thing I want to get to is this guy here and tell you a little bit about the review and how I'm going to do the review and whatnot. So first, in coronavirus updates, I don't know if this is what it looks like on your side, but this is what it looks like for me. You can get about the same information there, probably more from that PDF I already looked. But if you go here, AP exam schedule, there's some math specific information I want to talk about. All right. So AP exams, your exam is May 12th at noon. All right. You want to tune in about a half hour before and be ready, and then you go at noon. As far as the actual math of it goes, which is what I'm interested in, some information. Your exam is 20 or two questions. One that's a 25-minute question, and that's 60% of your grade, and another that's a 15-minute question and 40% of your grade. The way the exam is structured is you begin, you have 25 minutes to work, and then they give you 5 minutes to upload. Um, I'm not sure if it closes out the question and you have 5 minutes to upload. I just know you can't work ahead. So 25 minutes and 5 minutes to upload your solution. Again, watch those videos that the AP or College Board puts out as far as how that goes. And then you wait around if you finished early until the next question opens, and then you work on the second question. You can expect that these questions are going to hit a lot of different areas. So it's not going to be one question about just this motion. I mean, they're going to try and cover as much calculus with one question as they can. So yes, they'll cover motion, but you'll also have to show you can use sub and take a derivative and all this great stuff, fundamental theorem of calculus. You can imagine they are going to try and hit as many things as possible. And you can also imagine they'll probably put a question in with graphs and tables and equations, just trying to get it at as many angles. So expect that. Um, this bad boy um, is what they are talking about as far as what's on the exam and what's not. Units 1 through 8 are mostly just Calc 1. 8 is applications of integration. There is some Calc 2 stuff only in there as far as improper integrals and whatnot, but that's a lot of Calc 1. You can see Unit 9 is not on there. Let me pause this video for a second, and I want to get a chapter, a unit look, just a second. Okay, so it says 1 through 8, and there's little bits and pieces of Unit 10 here. Let me make clear what that's looking at then. So Unit 9 is not on there, and so that includes polar, go away, parametric, polar coordinates, vector valued functions. So basically, you know, a good third of Calc 2. Just left off, just like that. That's cool. So Unit 10, let's look at the ones they're asking for. No, wrong tab. They say you are going to actually have to know 10.257811. 257811. Let's look at those. 2 is working with geometric series. That's good. We're good at those. 5, harmonic series and P series. That also is easy. Did they say 7, 8, 11? Oh, my memory is so bad. 7, 8, 11. 7 is alternating series test for convergence. 8 is ratio test for convergence. And 11 is Taylor polynomials, approximations of functions. All right, so that's what is on there. And let's make sure that you're ready, shall we? All right, that's what I wanted to hit there. Now let's get to the math. Over the course of this, we're going to do some series problems so you can really get polished on those and do well on the test next week. And then we're going to have 2 free response problems, and then you are going to make corrections as necessary. I'll give you the answers, and then you can watch the videos, continue to watch the videos for corrections if you need to. And then if you'd like to hang around, I am going to go over the common errors that our class made on Unit 1 and 2, multiple choice and free response. So here we go. You should have found the document, and maybe you've already done these waiting for the video. I apologize. And so you should have the document that has this warm-up, all right? I will give you the answer that I have to this, and if you need, you can listen to the explanation. So I used sum of 2 terms to get the estimate, and it was 1.7239. I used the third term, was error bound, and it was less than a tenth, so that's when I needed 2 terms, right? Now, if that's what you had, or if you had something like 2 to the 7 halves over 5 minus 2 to the 9 halves over 42, then you're good on this one, and you can fast forward through my explanation to the next question. All right, so if you missed this, then let's figure out why. First, we need to develop a series for this guy, and so I know that sine of blank is blank to the first minus blank cubed over 3 factorial plus blank to the 5th over 5 factorial minus blank to the 7th over 7 factorial. I didn't know how many terms I would need. Then I said, all right, now I'm going to substitute in root x into the series. That's one of the skills you definitely need to know about series, is how to use substitution to avoid from having to take all the derivatives on this. Yuck. All right. So at that point then, sine of root x is x to the half minus x to the 3 halves over 3 factorial plus x to the 5 halves over 5 factorial, and so on. If I then multiply by an x, then I'll bump every power up by 1. And I get something like this. So if I integrate, I go 0 to 2 of the integral of the sine function or expression will be approximated by this. And so if I'm going to integrate x to the 3 halves minus x to the 5 halves over 3 factorial plus x to the 7 halves over 5 factorial, don't know how many I'll need, but let's integrate. So x to the 3 halves integrated is 2/5 x to the 5 halves. X to the 5 halves integrated is 2/7 x to the 7 halves over 3 factorial. Feels like I have a mistake in my answer there. Maybe I couldn't read my own writing. All right, well, we'll see. And then 2/9 x to the 9 halves over 5 factorial and so on, evaluated from 0 to 2. If I evaluate at 2, I get 2/5 to the 5 halves minus 2 over 42 times 2 to the, now I understand why my answer is that, 7 halves, plus, if you like, I can continue on, 2 times 2 to the 9 halves over 9 times 5 factorial. All right, now this is an alternating series with terms decreasing in absolute value to 0, so we can use error bound. We need the first term that is less than 1/10, and I think you'll find it's that one. And so because this is, I'm going to say this is, my approximation is S2, which is what my answer is, and I say this error is less than 1/10 because it's an alternating series. Conditions met, S minus S2 is less than or equal to A3, which is 2 to the 11 halves over 9 times 5 factorial, which is less than 1/10. All right? All right. Okay, second one, people. So, if you were to give this a go, the first thing I would do is think, do I need to do the ratio test? And it seems like they're giving me -2 to 2, but then, I don't know, maybe it works for all real x's. Well, rather than do the ratio test to get the body, I just said, what if x equaled 5? Well, if x equals 5, this thing's going to get crazy big, and so that's a no. The terms wouldn't go to 0. So I'm going to bypass the ratio test and just focus on the endpoints so I can choose between A to D. By the way, the answer is C. Sorry. If you're checking your answer, the answer is C. If you got C, then move on to the next question. All right. If you did not get C, then let's see why. So x equals -2. The series becomes something like this. Okay. Now, you could make terms, and if you're not sure how to do the algebra of this, you could. But I would break that -2 to the n up in the -1 to the n. Actually, maybe I would just multiply these. If I would put these together, because they're both to the n, then isn't -1 times -2 2 to the n? And if you have a 2 to the n in the denominator, that then diverges because it's a p series with p of 1/2. But if x is +2, then it is an alternating p series, and so that does converge conditionally, and so that's where C came from. Okay. All right. This, your answer is C. If you got C, then and you understand it, then feel free to move on to the next question. If you did not get C, then let's talk about why, shall we? Let's start with x minus sine of x. If the series for, I'm not going to try and do too much. I'm just going to do this a little at a time. The series for sine is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and so on. So throw in the series. Let's simplify up top. the x's subtract away, and I'm going to get a sign change. So I will get something like positive x cubed over 3 factorial minus x to the 5th over 5 factorial. Don't know if I need to do the general term. I'm going to hold off on that. But if I then divide out an x squared, then everything's going to reduce in power, so I'd have x to the 1st over 3 factorial minus x cubed over 5 factorial, and so on. And that is C. Okay? All right. Really quick, checking your answers for this, and again, going over the details. For this, for A, I have something like 3 minus 2x plus 3 halves x squared minus 23 twelfths x cubed. For B, I have 3 plus x squared. C, 97 48ths. And D, I was proving basically that the error bound was, in fact, 0.45. If you, rather than use this video for corrections, you'd rather look at the scoring guidelines and the work there, then it's the 2019 BC. If you just Google 2019 BC scoring guidelines, if that helps you learn better, do that. I don't care about the scoring. I just care that you understand the math. So I expect you to make corrections, preferably in ink, and show me you understand. I want you to learn. I don't want you to grade necessarily. All right. So if you want to skip forward to any part that you struggled with, go for it. I'm going to start on part A. All right, so write the third degree Taylor. So we know that a third degree Taylor is f at 0 plus f prime at 0 x to the 1st over 1 factorial plus f double at 0 x squared over 2 factorial plus f triple at 0 x cubed over 3 factorial. That's third degree. Now we need to gather our info. F at 0 can be found from the graph. It is 3. F prime at 0 can be found from the graph. It's the slope of f at 0, which is the tangent line slope. And so that's down 2 over 1. 2 over 1. F double is in the table. Here's the second derivative, and that's 3. And f triple is in the table. It's negative 23 twelfths x cubed over 3 factorial. All right. And negative 23 halves. That's why that seems wrong. Negative 23 halves times 3 factorial. All right, cool. So that's part A. Part B. This one's pretty gross. So we're multiplying. So it starts off easy. What's the series for e to the x? You should know that. So 1 plus x to the 1st over 1 factorial plus x squared over 2 factorial. That's the first 3 non-zero terms. We've got that done. Check. Right, the second degree Taylor for E times F. Well, E times F is the series for E times the series for F, and I'll have to go through at least the second degree of each. So 1 plus x squared over 2 factorial, and the series for F through the second degree is 3 minus 2x plus 3 halves x squared. 3 minus 2x plus 3 halves x squared. All right. So let's see here. If I distribute the 1, okay, sorry. So if I distribute the 1, then I'm going to get something like 3 minus 2x plus 3 halves x squared. Distribute the x, I get 3x minus 2x squared. And distribute the x squared over 2 factorial, I get 3 halves x squared. So combining like terms, the total constants, 3, total of the x's look like x, and the total of the x squareds, I have 6 halves x squared, which is 3x squared. 6 halves x squared, 3x squared minus 2x squared is x squared. Is that what I got? That doesn't look familiar. Yeah, I guess so. Okay. All right. You get the gist? And then you don't worry about the bigger degree. You just need to go through x squared. All right. See, now we're starting to get into some gross ones. As usual, A and B are nasty. By the way, I don't. If you read some of the information, they're starting to say that you might not get through all the parts. There might be a lot of parts to questions. So all the free responses we're used to have at most 4. Sounds like there might be more. So budget your time well, and do as much as you can. All right, back to this question. CH is this guy used the Taylor found in part A to find an approximation for H1. Okay, so H at 1 is approximately the integral from 0 to 1 of the series we found in part 1, which was 3 minus 2 plus 3 halves. 3 minus 2x plus 3 halves x squared, and then I can't remember, I think that was 23/12 x cubed. Nope, that's the wrong way. X cubed. What is 23/12 x cubed? Okay. All right. Use the Taylor polynomial found to find an approximation for H of 1. All right. So here we go. We need to integrate first. 3x minus x squared plus 3 halves times x squared over x cubed over 3 minus 23/12 x to the 4th over 4 from 0 to 1. I plug in 1, I get 3 minus 1 plus 1/2 and minus 23/48 and minus zeros on the back end. So I get something like, what? 2 plus 24/48 minus 23/48. So that's 2 and 1/48, which is the same as 97/48. You follow me? And that should be an approximation. All right, good notation and all, but silly. All right, it is known the Maclaurin series converges for all real numbers x. All right, so that means we can use a series to estimate anything we want. All right, so they're meeting the error bound. I assume they're going to error bound time. Show the approximation we just had differs from H of 1 by at most 0.45. So because the series meets the alternating series error bound, sometimes called the Leibniz theorem, converging, it is true that the difference between H at 1 and our estimate of 97/48, which is the same as the true infinite sum, and S of, how many terms did I add? 1, 2, 3, 4. And our sum 4 must be less than or equal to A5. A5 would be the integrated form of the series for f the f term there. Now that would be the fourth derivative at 0, x to the fourth over 4 factorial. That's 54 from the table, x to the fourth over 4 factorial. That's 54 over 24 is 4 factorial. And the antiderivative of x to the fourth is x to the fifth over 5 from 0 to 1. If we were to do a little simplifying here, 54 over 24. By the way, I didn't allude to this, but the calculator, the graphing questions will not be graphing calculator necessary, and not every kid has a graphing calculator at home. So get used to using your old forward function calculator, although you can use a graphing calculator, you just won't need it. So back to this. If I divide out a 6, maybe I'll get a 9 and a 4 and substitute in. And therefore, because A5 is 9/20ths, which is 0.45, it must be the case that the error is less than 0.45, or at most 0.45. All right, that's it. How did that go? Good, good. All right. This guy, let me give you the answers to this so you know whether you need to move on or go look at more work. So let's go. The answers to this, sorry, are for A, I got 1 over root 3. For B, I had something like negative log of the 6th root of 2, although that could have lots of different forms. In this, I got that it diverged. That is actually a lot of proofy kind of work, not just diverge. But yeah, so if that's what you got and you feel like you killed it, then you don't have to watch this video. But if you feel like you have corrections to make, then you should pick up your red pen and let's go. All right, so find the value of k, so the slope of the tangent line, the graph at 0 equals 6. So you would say the derivative at 0 needs to equal 6. Well, the derivative is something like that to the negative first. So when you take the derivative, it would be negative 1 comes down, that to the negative second, times the derivative of the inside, 2x minus 2. Evaluated at 0 is negative 1 times negative 2 over k squared. This needs to equal 6. That means then that k squared is equal to 2 over 6. And so k is either plus or minus 1 over root 3. But it says k is positive. K is greater than 0 in the problem, so we can conclude that k is 1 over root 3. That's where it came from there. You follow? Setting the derivative equal to 6 and then executing the algebra. All right. For k equal negative 8, find the value of. So let's start by plugging in negative 8 and seeing what happens. X squared minus 2x minus 8. Well, all right, so this is integration technique. So a lot of ways to go about this. The easiest way is the one that you should look for. So I hope you're not looking at trig sub or completing the square to use arctangent or something crazy, but instead think partial fraction decomposition. So I'm going to come back to this when I have it decomposed, but I'm going to use quality work and decompose this. Remember, this is strangers reading your work, and they expect, and you should show proper notation, good calculus. They don't know you. They're not going to cut you the benefit of the doubt. Show you know what you're doing, please. So those of you who do a million things in your head and skip steps, you need to leave that behind on the AP test and show the work. So for example, this is what I would consider bare bones kind of work. If you let x equal -2, then you get b is -1/6, and you let x equal 4, then you get a is 1/6. So showing that work, you then bring your results back to your integral, and you say, I'm going to integrate 1/6 over x minus 4 and -1/6 over x plus 2. At that point, then I check for continuity. I think you'll agree that the asymptotes, so I'm going to erase this to give myself some room. The asymptotes are at -2 and 4, and so continuity is not an issue. It is continuous over the interval they ask about. So let's integrate. I get 1/6 times the log of the absolute value now. Be careful, x minus 4 minus 1/6 log of absolute value, x plus 2, from 0 to 1. And then if you throw in, it's up to you now. I debated, should I combine the logs or not? I will say this, if you combine the logs, then when you move these up and make a division, the absolute value, it stays. It doesn't go away. It's x minus 4 over x plus 2 from 0 to 1. And then when you put in a 1, you get a log of 1, which is 0. And when you put in 0, you get log of the 6th root of 2, 4 over 2. All right? So it's negative. Again, it depends on whether you move the exponents up and use log rules or not, but you could have a couple different answers. That's the idea. All right. Last but not least, what if k is 1? 0 to 2 of 1 over x squared minus 2x plus 1. If that's the case, then let's look at factoring this again. Okay, now we've got a problem because we have an asymptote at 1 and it's not continuous. And so this is really saying, do you know what to do when you have an improper integral? And the answer is yes, I do, because my teacher taught me. The log as a approaches 1 from below, let's just write this as x minus 1 to the -2nd plus the limit, I think I said log, I meant limit as b approaches 1 from above of x minus 1 to the -2nd. The antiderivative, every time you get a definite integral, you should be writing, an improper integral should be written with limits. You should show the antiderivative. Again, do not skip steps. Of course, if you're one of those skip stepping brilliant people, you're probably not even watching this video. You probably already said, whatever, I got it. So it's just you and me, great kids. So at any rate, the limit as a goes to 1 from below, when a goes in, I get -1 over a minus 1 plus 1 over 0 minus 1 plus the limit as b goes to 1 from above of -1 over 2 minus 1 plus 1 over b minus 1. Now, as a gets really, really close to 1 from below, like maybe 0.999, this is going to be a small negative. A negative divided by a small negative is a huge positive. That's plus 1. And I don't even know if you continue because I can't combine these logs. So it's not like it's an indeterminate form that I can figure out. And so this is going to be fails to converge. And so I'm going to go with diverge. It's not an indeterminate form. They're both positive, so it's infinite, and therefore we say diverges. Okay. All right, that is the deal and what your work should have looked like. Now, this part is optional. If you've correct, holy crap! Oh, okay. A quick note about some common errors, and remember, I just told you the your AP exam, although it's BC, it covers 1 through 8, so it's worth looking at what are the big ideas of units 1 through 8. So today, unit 1, limits, typically limits would only be about 4 to 7% of a normal exam, but this year, who knows? These are the big ideas of limits. For the most part, you guys have been doing limits forever, although were a few commonly missed questions. Um, Continuity definition, that's probably something you want to get in your notes as a reference in case you want to refer to it during the exam. We're going to have to develop a reference sheet over the next couple weeks here, okay? And let's just, these are the big ideas. Feel free to pause and read through them of limits and continuity. IVT involves some writing. All right. This was a multiple choice question you took about 3 weeks ago now. More than half the class missed this question, all right? So you might have thought it was a total layup. You thought, geez, I don't know why I missed that. You have this fourth degree equation. This is calculator active, by the way. And for how many values of b does the limit approach 6? Well, in this case, it's continuous, so the limit and the values would be the same. If you look at the graph, which I put up here, it's how many values does it approach 6? Well, 6 is just right there, and I didn't know if I could have drawn y equals 6 in there, but I didn't know if I were getting 1, 2, 3, 4, or is that just 1? Is it barely maxing out there? So I found the max, and the max is actually at 6.01, which is to say it goes a little above, so there actually are probably 2 values there where x is 6, and then there's 1 over there, and then the question is, should we go with 4 then? Well, again, I think some of the issue is not reading the question carefully. Some people chose 2, and I can only assume those are the people that thought there was a max there but didn't investigate because they're lazy. And some people chose 4. Now, I understand 4, but you didn't read carefully. It says, for how many positive values of b? And so there are only 1, 2, 3 positive values, all right? So read more carefully. This guy, gosh, look at that. 8 people got this question right. Now, um, the table gives values of g, and they're saying which of these cases about the limit must be true. And so people have thought, oh, okay, it's a layup. I can just go as fast as I want to go, and as x approaches, it looks like the limit as x approaches 2 is, yeah, these are definitely approaching 8. And that's what you chose. You said 30 people said, yep, the limit is 8. And you, of course, are wrong because you didn't read this word. Must be true. We got to 1.99999 and 2.00001. There's a window there. And we got y values between 7.95 and 8.05. Now, to assume that 8 is the limit is folly because there are infinitely many numbers it could be just in this range. There are infinitely many possibilities. So to say it is 8 is a huge leap, and the overall sin you're making is reading too much in from a table. A table tells you exact points. It doesn't tell you everything, and so it doesn't have to be 8. Shame, shame. And then this guy also, this one's actually really hard. Oh, this is a math teacher's problem. They would write that. So for this function is equivalent to which of these? So I imagine all you people that chose this, 18 people said, well, shoot, the limit of this is the same as the limit of the top over the limit of the bottom. That theorem, the limit of f over g is equal to the limit of f over the limit of g, that's dependent on only if the limit of g not being 0. Otherwise, they are not necessarily equivalent. You might have L'Hopital, might have a lot of things going on. So You committed maths in there. This is the answer, as you can see with the green bar, and it's really just algebra manipulation. If you took this guy and rationalized it, then the x minus 4 drops out, and you'd see the x plus 2. All right, so that's that. This is the free response in Unit 1, and it was not really hard at all, so I don't want to waste your time. This is just limit rules. It was pretty straightforward. I will say this on these values, when you say for which of these values is this continuous or not, use the definition of continuity, they expect you to use good notations. So limit notation and left-hand, right-hand approach and knowing the definition of continuity. Again, why doesn't the limit exist? If you claim that the limit doesn't exist because the left-hand, right-hand limits are the same, then use proper notation. And then this one was the only one that was, I think I went the wrong way. This one was the only one that people muffed a little. The vocabulary there, those are big words of calculus. Difference quotient. And so if you look at a difference quotient, you're talking change over an interval. And when you take the limit on that, that's the derivative. So the difference quotient is the foundation idea of the derivative. So you should have been saying something like g at 1.001 minus g at 0.999 over. That's a difference, a quotient of the differences, yeah? You get the idea. All right. Unit 2. Unit 2 is getting pretty soft again. It's not super duper hard. On a normal year, this would only be about 4 to 7% of your exam. It's basically just taking derivatives. Do you know the definitions of the derivative? Do you understand the idea of approximating a derivative with average rate of change? Make sure you write it well with an approximation sign. You've made that mistake a million times, right? And then all the derivative rules. I mean, if you don't know the product rule by now, then geez, give it up, all right? Some commonly missed questions on a Unit 2. This is Unit 2. This one boggles my mind. I can't say, maybe going too fast because it was Friday and you're just being careless, but which of the following is the instantaneous rate of change equal to the average rate of change? Kind of the core idea behind average mean value theorem, but average rate of change between A and B is, oh, maybe you connected, no, I don't know what you did, but here's the average rate of change, yeah? Now you want to try and find a place where the tangent slope, the instantaneous rate of change, is the same. I think A obviously is ridiculous. B is a maybe. C is too steep. And D's dumb. So C, why did you choose C? Why? More of you chose C. Are you kidding me? That slope is the same as that slope? Why? Are you kidding? You must have had a hot date that weekend. No, you can't have a hot date. It's coronavirus. What the heck? So I don't know what's going on there. This one, 13 of you missed this, which isn't a lot, but it's still way too many here. Really quick. If true, which can be used to conclude that f at 3 exists? Does the fact that the limit exists implies that the point has to exist? The answer is no. If f is continuous at x equal 3, well, f cannot be continuous at 3 unless f at 3 does exist, so that's a yes. If f is differentiable, then it's continuous, and therefore that's a yes. And so 2 and 3, and I'm not sure why people said 2 only. Differentiability implies continuity. I don't know. All right. And then real quick, the free response on Unit 2. It was also pretty straightforward, using a graph and an equation. So I told you before, you can expect lots of different approaches to calculus in these questions. This is comparing graphs and analytical. But product rule, Read the graph carefully, I guess, is all to that. Quotient rule, you could pull the fifth out, or you could put the 5 in with the function in the low, but that one wasn't too bad. Um, this one also went pretty well. From -3 to 1, is our place where f prime equals h prime. So f prime, there you'd use the slope of the f graph. H prime, you take the derivative of h, and then use your graphing calculator to solve the intersection. That was pretty clean. And that's it. Now, if there's anything you feel terribly rusty on units 1 and 2, I'll unlock basically everything I can find for units 1 and 2. And if you want to practice more for response or more multiple choice, that's fine. Gosh, now that you've come to the end of this video, I meant to tell you something at the start of this video, and that is, on the next exam, I might consider using some of these questions to see if you learn from your mistakes. So I guess if you're still listening, then good for you. You'll be rewarded. Have a good day.